love those dramatic pauses. Our next speaker is Grant Skinner, who's the creator of easel.js and also Pirates Love Daisies, which we saw a glimpse of yesterday. He'll be talking about HTML5 gaming today. Please welcome Grant Skinner.
Hello, everybody. I'm glad to be here. It was an exciting trial getting here, but I made it at last. I know Doug is probably bordering on a heart attack because of me. So I just really quickly want to give you a little introduction, basically where I'm coming at for this topic. Up until about a year and a half ago, my company, gskinner.com, was almost entirely a Flash company. We did little bits of iOS and stuff like that. But we were approached by Microsoft about a year and a half ago, and they said, you know, we've seen what you do with Flash. We really want to see what you can do with web standards. Specifically, we'd like to see what you can do in the gaming space. We'd love you to prove that it's possible to build a cool game on top of HTML5 and show off the GPU capabilities that IE9 had. And we were a little bit suspicious of this. You know, being a Flash company, we weren't so sure we wanted to get into the world of JavaScript. But at the end of the day, things went really well, almost surprisingly well, and we wound up building this game called Pirates Love Daisies. And at the time, it really pushed the envelope for what was possible. And it was specifically designed to tax the systems of the day, right? To push graphics as far as it could go in HTML5. And I'll come back to that a little later on to talk about where we've gone since then. But, and so since releasing that, we've become fairly well known as an HTML5 game company, which for us is actually a pretty big jump from where we were a year and a half ago. But it's been an interesting ride. And so today I'm here to talk to you about games on web standards, both today and also where they're going in the future. And I'm going to frame this talk around the idea of what do we need to make a great game? What are the pieces that contribute to making a great game? And I'm going to talk about how current web standards satisfy those needs, and perhaps more importantly, what web standards are in progress right now that will make things easier. This isn't going to be a really technical talk. I'm not going to be showing code. I'm not going to be talking a lot about specific browser support. I'm not going to be showing you, can I use matrices or anything like that. I just want to sort of skim the surface of all of these different pieces and give you an idea of what's available and what's coming. And then I'll leave you to go out and do your research on your own. So what do we need to make a great game? Well, to start off with, we need an idea. And obviously, web standards can't address this directly, but it can definitely influence it, right? We can gain a lot of inspiration, both from the technologies that we have available to us, right, the specific APIs and such, as well as from the medium that we're building on top of. And I think there are a lot of companies that are doing this well. Zynga springs to mind. But there's also a lot of games that are basically just being copied wholesale from past genres onto the web. And there's nothing wrong with that. But I think it's a really exciting time right now to look at our medium and say, can we build games that are designed for the web and really leverage the services, the social aspect, and the connectivity of this medium to build new genres of games and really engage users in different ways. And I think that's where things get really exciting. And so I'm not going to dwell on this and offer a lot of insight into it, but I just want to get people thinking about this, because I think this is really critical. I think we have a new medium and we have new opportunity to explore things that maybe haven't been done in the past. Once we have a good idea, one of the first things that our users are going to interact with in the games that we develop is loading, right? We have to actually get this game onto the client. And this is so while you don't think about it a lot, it's actually a fairly critical piece. So the first time that the user interacts with our game, we want to be able to show them some kind of progress bars. We download this game. And unfortunately, right now, this is somewhat challenging on the web. We don't have progress events on most types of loads. We can't tell the percentage load on an image or a sound or anything like that. But there are some ways that we can work around this. For example, one of the things that we've done is we've written a little engine and a tool that generates asset manifests. So we tell it what assets our game is going to load. It generates a little JSON file for us that includes the file sizes and the assets. And then what we do is as we load assets, we watch how long they take to load in. We get a sense for what the user's bandwidth is. And then we do predictive loading or predictive progress, where as we load the next asset, we apply the bandwidth that we calculated back against it. And we use a little bit of a hockey stick curve for our easing. So we load it we show progress fairly linearly. And then as we start to approach the sort of 90% mark, we start to slow down the progress just in case we've encountered some kind of hiccup. And that way, to the user, it looks like we're giving them real progress on the load, when in fact, we're really just faking it in the background. Another way that we can approach this is we're starting to see the XML HTTP request object, level 2, is starting to be implemented in some browsers. And this provides progress events. It also provides a mechanism for loading in binary assets and instantiating them. So images, sounds, these types of things. And so we can actually load our assets using HXR2, get those progress events, display real progress, and then generate binary assets off the data that we load. So it should be possible to write libraries that make this very easy to give true feedback on the load. Once users loaded that game once, we want to try and minimize how much they have to load the next time they visit the game. Of course, we have caching on the browser. We can take advantage of that. It's basically free to us. But it's nice to have a little bit of manual control over that. And we have a couple of ways that we can approach this. One of them is that we can use cache manifests, right? So we write a little cache manifest file. We point to it from our HTML page, our main HTML page, and it designates all of the assets that we'd like to keep in a cache for offline use. We can also do interesting things like provide offline redirects to assets that are dynamic, that are generated by the server. These are quite powerful and actually really easy to use. There's tools out there that'll generate them for you. The main drawback to them is that there's no granular update to them. When you change that cache manifest, it will download the entire game or application the next time it reads it. There's no way to just download one file that's changed. But we have ways that we can do this manually. We can take advantage of local storage. Local storage lets us store about 2.5 megs, so not a ton of storage there, but enough that we can cache a reasonably substantial web game. This is all manual. We have to download our assets by ourselves. We have to convert them into a string because local storage will only store strings. And then we have to retrieve them, and we have to write the mechanism to decide when assets need to be expired. And there are some libraries that are starting to evolve for this, and we've been writing some of our own. But what this ultimately means is that we get instant on with our games, which I think is really critical. When people play web games, they want to play them now. Otherwise, they'd go and they'd install a new desktop game. So we want to leverage these capabilities. Another really critical piece of building a game, of course, is graphics. And in the web world, we have an abundance of ways that we can display graphics, right? We have a bunch of different surfaces: SVG, the DOM, WebGL, and Canvas 2D. So let's take a look at each of these. I'm going to lump the DOM and SVG together because they work well together, and they both have fairly similar models and fairly similar constraints. Some advantages to them: they already have a scene graph, right? We're already dealing with objects in a display list. They have an interaction model, well-defined, easy to work with. They're ubiquitous, right? It's the heart of the web. It's everywhere. The DOM was the first hardware-accelerated surface. You look at things like iOS, older versions of iOS, and the DOM was hardware-accelerated. Nothing else was. And so it gave you performance on mobile devices that you really couldn't get with any other surface. The disadvantage to them is that they were never written to build games, right? They were never designed for it. And so they have fairly high overhead. They need to manage a lot of things. They need to, even working with them is fairly suboptimal. We apply things like transformations using strings that then have to be reparsed and interpreted. And so there's a fairly high overhead associated with them. They're very high-level abstractions, and so it's hard to optimize them. So when we look at performance today, now that we're starting to see hardware-accelerated Canvas and WebGL, we can see that maybe HTML and SVG aren't our best choices, right? This is demonstrating 1,000 particles being animated, and this is telling the frames per second that I can animate those 1,000 particles at using HTML DOM, SVG, and Canvas, which is hardware accelerated in Safari 5.1. And you can see that getting around 10, 11 times the performance using Canvas. And so while a year and a half ago, the sort of standard approach was to write your games to use the DOM as the rendering surface, today I think we've moved past that. Of course, we have WebGL. WebGL is based on OpenGL ES2. It's fast, low-level hardware graphics access. Because of this, it has a fairly steep learning curve. It's hard to get into. There are some great libraries coming out for it, like 3.js. And of course, advantages to this is we have full 3D full 3D graphics. We have vertex shaders. We have fragment shaders. We can do really amazing things that you can see on platforms like Xbox, for example. In the 2D space, we can do orthogonal projection. So we can actually render a 2D scene, and we can leverage fragment shaders to do really interesting effects on the 2D space. So there's a lot of opportunity to use WebGL for 2D games as well as 3D games. It's a little less broadly supported, though, than something like Canvas or the DOM. Quick example of this, and I chose this partly because it's really pretty and partly because it loads really fast. So this is all WebGL, and a lot of people I'm sure have seen this, but this gives you an idea of what's possible with this technology. Our third option is Canvas 2D, and Canvas 2D is quite ubiquitous. It's fairly broadly available. It's an older standard. I believe it was first proposed in about 2004. It's on almost all mobile devices, most desktop, basically all modern browsers support it. It's probably the most consistently implemented API I've ever worked with on the web, almost shockingly so. Very little browser-specific issues or variants in the API. Very easy to get started with. A couple lines of code, you can see something getting drawn on the surface. So it's very linear in terms of learning. And it's becoming increasingly performant. We're starting to see it become hardware accelerated, and so we're seeing results like this now. So comparing desktop Safari 5.0 to 5.1, where 5.1 got hardware acceleration, we're seeing about 5 times the performance in a benchmark tool called Game Test 1 that I wrote, which just tests how many sprites we can push around at an adequate frame rate. More amazingly is when we look at mobile and we look at iOS 4 with Safari 5.0, and where we could push around about 50 sprites at 20 frames per second, which really isn't enough to build a game when you add other overhead. But in iOS 5 with Safari 5.1, we can push around about 2,000 sprites. So, and that's on an iPad too. So this is the peak of what we could build on Canvas using iOS 4. We built this for a gaming magazine, and we had to use every trick in the book to make this run well. It only runs at about 10 frames per second. Every piece of graphics that we can have gets cached off, and even then it didn't run phenomenally. Whereas today, on an iPad 2, we can run Pirates Love Daisies without any edits to it. It slows down a little bit in a couple of key places, but we could make a couple of really quick edits to it and it would run just fine. So it's a huge jump from an experience like this to Pirates Love Daisies. It's really important, though, to remember that we're not locked into one of these. We can combine them, right? They're just all elements in the DOM. So we can layer them together, and we can leverage them for their strengths. So HTML DOM does UI really well. So in the games that we've built, all of the UI is done with HTML. Everything you see here is all in HTML. And then when we actually jump into a game, the game map, the portal onto the game, that's Canvas. But all of the UI around it is all HTML. And we've actually done some things to make this easier inside of Easel, where you can actually have a display object that is, in fact, a DOM element, and our display list will manage that DOM element and move it around and alpha it out and things like that. You don't need to deal with display lists as separate entities. You can combine them into one scene graph. The other way that we can work around this is if we're not sure what the future holds, if we don't know, is the future WebGL or is it Canvas, or maybe we still need to target the DOM for certain mobile devices, we can use pluggable renderers. So for example, 3.js, a great 3D library, it will render out to Canvas 2D or it'll render out to WebGL. Obviously with a lot of caveats on Canvas 2D, especially when it comes to performance. Easel.js right now, we have an experimental build that we're working on that has pluggable renderers where you can basically just swap the renderer out and have the same content run in all devices. So this is a quick demo of that where this animation is exported into Easel.js. This is running on the canvas right now. Oops, let's reload. This is running on the DOM, SVG, et cetera, right? So we can write our content once, and if we decide on this device we should run it on the DOM, we can switch one line of code, use a different renderer, and have it run performantly there, or we could have it run on WebGL, and we can choose what our surface is based on our environment. So graphics are in a pretty good place. Let's look at sound. Sound is maybe a little bit more challenging right now. We have a couple of options, the most prominent being the audio element, the audio tag. It's pretty broadly supported, but it really suffers from a lot of browser-specific issues. There are bugs, differences in latency, different formats that we have to deal with, right? OGG versus MP3. Each browser has a different maximum number of audio elements that you can work with at a time. And this is really challenging to get around because this isn't a maximum number of channels or maximum number of sounds. This is a maximum number of actual audio tags that you can have running at the same in existence at the same time, whether they're playing or not. And so for a game like Pirates Love Daisies, what we had to do is actually assign a certain number of sound channels to sounds that would play more often. So for example, we have this girl pirate who shoots a lot. So we gave her 3 sound channels, or 3 sound objects. And then the guy with the sword, we gave 2. And certain other sounds only got 1. And in order to get the lowest latency that we could have in that game for sound, we had to have those always instantiated. And it was definitely a challenge to get it to work. iOS makes sound extremely challenging. It's very limited what you're allowed to do in iOS. You're only allowed a single sound. That sound can only play on click. And so, the easiest way to treat this, and the way we treated this for a demo we built for Sencha a little while ago, is on click we'd place background music. So when you start the game, we start up the background music, get it looping, and we didn't have any sound effects in the game. But there are other things that we can do. So some solutions using audio tag. One of them is don't use it, or fall back from it, right? Use Flash. A lot of the games out there right now in HTML5 are using Flash for their audio, just because audio is still pretty difficult to work with. There's some libraries out there that can help you to manage this. So Sound Manager 2 will automatically use Flash as a fallback. Sound.js is a library that we wrote and open sourced, mainly targeted at games, and it basically manages a lot of that logic around interrupting previous sounds, assigning multiple channels to sounds, things like that, and kind of it abstracts it away from you. It's pretty purpose-built, though. It's hopefully will go extinct as soon as audio on the web gets better. And we can use advanced tricks like sound sprites. So similar to graphical sprites, we can put a bunch of sounds into a single track, and then we can have little gaps in between those sounds, and we can play a bunch of audio tags all with that long sound in it, and we can jump around inside of it. And you can actually do this in iOS. So you can have a bunch of sound effects, and you can jump between them and only have that one sound start playing when the user clicks to start the game. So it's hacky, but it works. The only trick is that latency is a little bit different on different browsers. So you can't be, you're not going to be anywhere near sample correct. You have to accommodate a little bit of latency. But we do have a better option kind of in the wings. There's the WebAudio API. And this is a very powerful API for manipulating audio. It's sort of the WebGL of the audio world. It's fully sample correct, so you can specify exactly when you want a sound to play. It has a bunch of native nodes for sound manipulation, so they run at native speed. And so you can get a ton of different effects with them that just come for free. You can write, you can use JavaScript to do audio synthesis or audio manipulation. So you can manipulate audio directly. Kind of expensive, though, because JavaScript is not really designed for this task. And it's also going to have analysis tools and, of course, mixing tools. And so you can do some pretty neat stuff with the WebAudio API. Right now, limited support, starting to get some traction, though, and it will solve a ton of these problems. I'll show you a quick little example of this. This came out just a few days ago. I think. Oh, no, maybe it didn't. I just found this a few days ago. Oh, sorry. I need to just open this in Chrome. Otherwise, I don't have a nightly here. OK. So this is doing some vocal synthesis. It's actually using pre-recorded samples. And it's basically generating all the instruments just using audio synthesis. So, and as you can see, it's all, the timing is correct. There's no audio glitches. So this is where things are headed. Not necessarily with bad Japanese pop music, but in terms of capabilities. So we have our game loaded. We have nice graphics. We have audio playing. Now we want the user to start interacting with our game. What are our options here? We have, right now, we can obviously capture keyboard strokes, right? This is a standard part of JavaScript. We can't capture every key right now. For example, Command or Control key. With certain combinations, won't get passed into the application. This varies a little bit between browsers. This isn't really a big deal for most games, but more complex games where you might want to, for example, crouch while holding down the Windows key and use the WASD keys to navigate. It can cause problems there, but it's not a big deal. It's pretty adequate for what we need. Built-in mouse interaction model right now is adequate for most point-and-click games. Not great for things like first-person shooters, but we'll talk about that in a second. WebGL and Canvas, we have to write our own mouse interaction layer. Those elements don't really understand the content inside of them, right? Canvas is, once you draw something on Canvas, it's just pixels on the surface. It doesn't understand, it doesn't have any concept of objects once they've been drawn. And so we need to write our own mouse handling systems. So in easel.js, for example, we have this trick where we basically manipulate the concatenated transformation matrix when the user clicks on the stage to draw appropriate elements to a single pixel canvas, so that only one pixel has to be written and only one pixel has to be read, and we check to see whether or not that pixel changes color. And if it does, we know that the mouse is over top of the element we just drew. So it's actually very performant because we're only ever having to render that single pixel. But again, this is where libraries are nice, because that way you don't have to write it all over again. We're starting to have some more options coming out for doing more advanced interaction. We have the full screen API, which lets us take content full screen. It's a little bit quirky still. I'll show you this. So that's what Safari does when I go full screen. And this actually isn't too bad. Sometimes Safari, I'll actually have parts of my desktop drawn into my browser window. I'm not sure if it's an issue with the hardware implementation that's getting a little bit corrupted by this, or if it's just general weirdness. But full screen works pretty well if you point it at a single surface, if you point it at a canvas, or you point it at a WebGL instance. I've seen some quirky behavior when you have a bunch of content layered on top of it. So if you're doing your UI with HTML and CSS, you might still get some strange results that you have to debug. Mouse lock, the web events group is working on mouse lock and synthetic mouse events so that we can capture the mouse for games like first-person shooters where there is no real edge to the world, where we want to be able to keep pushing our mouse in a direction and have our character continue to look in that direction. But then we might layer UI on top of that, and so we still need to be able to translate that sort of infinite bounds mouse back into real cursor events. And so we'll be able to generate mouse events synthetically and push them back out to the DOM or back to elements. The gamepad API, also being worked on by the web events working group, will allow us to access joysticks and gamepads and those types of things, so we can tie that into our games. And then, of course, we have devices, which is a huge thing that we need to consider. And you just saw the other grant. We're the W3 apparently today. Just about touch events. API is great, very robust. Get a lot of data out of it. We have an orientation change API so that we can tell when phones get rotated. Kind of confusing naming, but the Geo working group is working on the device orientation API. And this will give us access to device's compass, its accelerometer and gyro, basically all of its positioning data in space. And I haven't seen anything specifically dealing with orientation lock, but I know that there's awareness that this needs to be addressed. When you have a game on a phone, you don't want that game constantly reorienting when the user's spinning around their phone playing the game. And so we need the ability to lock the orientation. And I know that there's awareness among browser vendors that this needs to be done, but I haven't seen a specific spec dealing with it yet. So we're on the web. We want to make this game use services. We want it to be multiplayer. We want to talk to our server to record high scores. So we need to get into communication. I love this picture, but I'm a Star Wars nerd. So what are our options? Well, the most broadly used option right now is the XML HTTP request object. Originally just for getting asynchronous XML. Now it does pretty much everything, right? It can be used for getting plain text data like JSON, but it can also be used for getting binary data. And so a lot of people use this for like polling, for simple multiplayer, and for doing things like high scores. We have WebSockets, pretty broadly supported. Right now, text only. The spec includes binary, so we should get binary support at some point in the future. And this lets us do much more real-time communication with the server. And we use this, for example, in the Tankster game, which I showed briefly, to do multiplayer. where we have fairly low latency between players, where we push an action to the server over a perpetually open socket. It pushes it off to the next player. So we can both push data, and we save the cost of having to reopen an HTTP request every time we want to send data back and forth. Upcoming, we have WebRTC, and this builds on top of the peer connection API. And this will basically let us create peer-to-peer connections to send data, but also to send audio and video. So we can get into cool gaming scenarios where we have very low latency communication between the peers, and people can also do audio chat or video chat as they're playing the game. And that opens up the door for really interesting collaborative or competitive experiences. And as part of HTML5 as well, we have network status. And this is supported pretty much across the board, and it lets us just tell when our connection's been severed and when it returns. And so we can deal with that on the client now. Of course, we're going to have to write a lot of code, right? We're building a game. There's a lot of code that's going to have to get generated. And the good news is performance has gotten way better with JavaScript. In the last 3 or 4 years, average, I'd say, is about 10x increase. Obviously, it depends on which browsers we're looking at. The real standout, although part of this is because it used to be really bad, i.e., over the course of about 2 years, 100 or about 15x increase in performance between IE8 and IE9. And this means that we can run complex algorithms. We can do real-time 2D physics. We can do pathfinding, things like this that used to be just would run too slow in JavaScript. We can write much more robust game logic. JavaScript, of course, can be a little bit challenging to write big projects with. And ECMAScript 5 is really working to try and address some of those challenges. So for example, we have strict mode. And I'd recommend any JavaScript you write from this moment on should use strict mode. It basically locks down your scoping, doesn't have implicit global scoping. It's backwards compatible, so you don't need to worry about whether or not your code will execute on older machines. And it takes a lot of the easy bugs out of writing JavaScript. We have some new methods for dealing with objects. We can seal methods. We can prevent extensions, so we can prevent people from adding new methods or new properties to our objects. We can basically reduce how dynamic our code is, right, to prevent other people from messing around with it. We can create much more advanced properties. We can specify whether or not they're writable, whether or not they're enumerable, whether or not they can be configured, so whether you can change properties on it. And again, this lets us get more errors, which is a good thing. It lets us know that something's going wrong instead of just failing silently or getting unexpected results. But it's still challenging, right? This is still a very dynamic language. We don't have type safety. We don't have interfaces. Inheritance is through the prototype chain. We have no real super keyword. And a lot of the popular implementations for super are very expensive. Things like prototype.js, inheritance model. It's great if you're doing sort of jQuery type work. If you're building a game engine, it's very expensive. Super calls are very expensive with a lot of these workarounds. Hopefully this will be addressed in the future, though. A lot of sort of structural keywords are reserved in JavaScript, so class, super, etc. The dynamic nature of JavaScript makes it great for throwing together games quickly. You can write a game really quickly because you can append properties, you can append methods, you can stick stuff onto the prototype. It makes it great for hacking together a game, especially a smaller game. It's still a little bit challenging, though, when you're building bigger games or you're working in a team, because it's really hard to track down where your functionality lives. Did someone append it on the object prototype? Is it being overwritten somewhere? It's hard to tell. But we have some solutions available to us. Google Closure picks up a lot of errors. There are a lot of good JavaScript IDEs coming out, which will pick up some errors in advance for you. I like to use WebStorm personally. There's a lot of sort of cross-compiler tools, things like GWT, playn, which let you take Java and compile it back to JavaScript. Hacks, which has its own intermediary language. CoffeeScript, Django, which takes ES3, compiles it to JavaScript. So these let us work with more robust or stricter languages to write our game logic and then compile it back into JavaScript. Finally, it's great if we have tools, right? We can do all of this stuff by hand, but having tools makes it a whole lot easier. We have pretty good dev tools right now. Again, I'm a fan of WebStorm. They don't pay me to say that. It's just after using a bunch of different IDEs, that's the one I've kind of settled on. It's by JetBrains, the same guys who do IntelliJ, so it has things like code complete and as you type error detection and things like that, which makes working with JavaScript, particularly on larger projects, a lot easier. We have pretty good debugging tools in all the browsers, and it continues to get more robust. At the end of the day, a lot of my debugging sadly winds up back in console.log, especially in a game where you have so many objects, it's hard to track the flow of logic sometimes using a stack trace. Profiling, we have really good profiling tools in the browsers for JavaScript. What we don't really have is a way of profiling the graphical side of things. On WebGL, there's an open source project called WebGL Inspector, which actually does a really good job, down to the point where you can actually select a single pixel in your WebGL surface and say, tell me what drew this pixel. And it'll back up through all of the draws that contributed to just that one pixel. So fairly granular information. Canvas 2D, unfortunately, doesn't really have this yet. So you can rely somewhat on system gauges, looking at what's happening on your GPU, what's happening on your CPU, and just benchmarking. We have a fairly robust set of benchmarking tools that we use on Canvas that we can stick on a new device, and it'll give us a pretty good profile of how that device performs with different types of calls. And of course, we can use JavaScript. We can monitor our frame rate. We can time how long things take. And I know that there's a push for more granular time access so that we can do an even better job of this. So that's all great for developers. What about designers? Because design is a huge part of building games. Options are still fairly limited, but there's a lot of new stuff coming out. On the 3D space, we're starting to see exporters for different 3D applications. For example, Inca 3D is an exporter for Maya. And so it'll export most Maya geometry and effects out to use inside of WebGL. Both for WebGL and Canvas, you'll typically use a lot of sprite sheets for any 2D game. And there's a bunch of different tools for this. There's the always popular TexturePacker. Their Flash Pro, the next version of Flash Pro they've announced will have sprite sheet export. And we have our own tool, which we've open sourced, which is called Zoe. And I'll show you that really briefly. And we have a new version of this coming out. Basically, all I do is drag a SWF on. A lot of 2D game animation happens inside of Flash. And so basically, I can let my illustrators and animators continue to work in an environment they're familiar with. They can export a SWF for me. I can drag it into Zoe. And I can specify some settings and ultimately export this out as a sprite sheet for desktop or mobile. And this will do interesting things. The new version that we're about to release does interesting things like frame culling. So it'll actually look at that timeline, and you can specify a threshold for how different frames can be. And if frames fit within that threshold, it'll reuse those frames. So it'll compact things down quite a bit. We also have tools like Wallaby, which is a tool from Adobe that exports Flash content out onto the DOM, so CSS and HTML, and SVG. We have a tool online from a guy called, I think, Cloud Professor, that will convert SVG into canvas calls. And so we can do our work inside of Illustrator, export it into SVG, put it through the tool, and wind up with a bunch of canvas calls. And I've been working on a new tool called the Easel.js export tool, which I want to show you briefly. Basically, it's a custom panel inside of Flash. So again, a tool that our animators know how to work with. And this is a sample FLA. And I have this robot symbol. It has a timeline that my animator prepared. I have some sound, some labels, more sound. And I even have a little bit of code on here. Of course, Flash doesn't understand JavaScript, so I have to escape it. So I stick it into this special comment block. And this will be injected into my timeline as well. And then all I have to do is specify an output location. I'll just show you briefly that I'm not tricking you. So empty output location, hit export. And so this is now running inside of Easel.js. In this case, it's running on the canvas. But you can imagine how with, and you can see the code executed, go to and stop back on hello, and change the text of that speech bubble. And with our experimental build, I can also run this content, as you saw earlier, in the DOM and SVG and WebGL. And so this gives us some tools to get these assets out. And it supports vector content, obviously animation, sound, a little bit of scripting. And it winds up outputting an interactive timeline for me. The last thing that we need to consider, and really isn't the focus of my talk, but is worth mentioning, is monetization and marketing. And I think this is one of the things that's kind of exciting about building web games, is that we're in a social medium. We can really leverage the web to market and monetize our games. And we're seeing a lot of services coming out to facilitate microtransactions and getting people engaged in games. And so I think more so than really any other environment, we have this sort of implicit way of getting our games in front of people, getting people excited about it, letting them share it, bringing their friends in, and ultimately, hopefully, enticing them to buy something. I think it's important to mention Flash as well. I don't necessarily think that Flash is dead, despite the image here. Flash is definitely a much more mature and consistent environment. It's more ubiquitous. It has more tooling. And honestly, it's more productive to build games in Flash right now. I can build a game much more cheaply in Flash than I can in HTML5. There's just less things to worry about right now. But obviously, it's not going to run in iOS. With the announcements from Adobe last week, it's not going to run on mobile, at least in the forever, right? They've stopped production of the mobile player. I can export it for air, but it's not going to run in the browser. And Windows 8 Metro isn't going to have any plugins, so it's not going to be able to run this content either. Moving forwards, if I want my content to run everywhere, I think HTML5 is going to be the choice. I think today, you still need to evaluate what your goals are. If I was going to build a marketing game that's going to have a really short lifespan, and I'm not too worried about mobile, I might still build it in Flash today. If I'm building a game that's going to have a longer lifespan, that I want to be around in 4 or 5 years, and I want people to be able to play on iOS, I think HTML5 makes a lot of sense for that. So to kind of wrap it all up, these are exciting times, right? There's so much change right now. It's really exciting to be involved at this point. It can be frustrating at times, but it's really awesome to be working to solve some of these challenges, to see all these new specifications coming out, getting to play with them, getting to see what we can do with them, and kind of being explorers in this space. Still some rough edges, but things are getting better fast, right? There's a lot of stuff in the pipeline that's going to make our lives easier building games. It's critical to do your homework. It's critical to test on multiple devices, to know the quirks of these individual APIs, to know how performance is on different devices, right? To use Canvas as an example, performance is all over the place, right? The performance on iOS 4 versus iOS 5, obviously very different. The performance on Safari for Mac versus Safari for Windows, very different. So you need to know who your market is, and you need to make sure that your content is tailored to that market. This will become something that you have to invest less time in very soon. So go forth and code. Build some fun games, and have fun doing it. I have to mention as well, recently formed a W3 community group for games specifically. If you're interested in the topic, definitely consider joining this group. I think we just today voted in our chairman. So this is on the ground. It's just starting now. So thank you very much. Now do we have time for Q&A or wrap it up and walk off?